looking at binomial function, but we're going to try and test a slightly sort of mastery understanding of what we're doing. Using our calculator is fantastic. It would take us so far. But this kind of question just tests us a little bit more. I've been summarise the information here that we're actually told, but I don't know what P is. That's what the question is. We want to try and work it out. So remember with these, pause it. If you're happy about working these through, just go ahead, work them through. You can have a quick check, make sure you're okay. All of these are in your PDF. But if you're not so sure, then watch a bit, and if you think you've suddenly got the idea, then pause it, and then you can move on. All right. So I'm just going to write down what I know. So just from here, and I'm looking at probability that x is equal to 2. So that's 8 choose 2, and that would be multiplied by p squared multiplied by 1 minus p to the 6. So that's what x equals 2 would be. Now we're going to do exactly the same for x equals 3. So here we go, and p cubed 1 minus p to the 5. Now this is going to drop out quite neatly. 8 choose 2, which if I just do that on my calculator, that gives me 28. And what I'm actually going to do as well is I'm going to divide, or I may as well put in 8 choose 3. 8 choose 3 is 56. But we're going to divide both sides by p squared. And if I divide both sides by p squared, that goes. The reason I can do this is it's all multiply. So over here, I only get that left, and that's gone. Fantastic, that's handy. And I'm going to do the same. I'm going to divide both sides also by 1 minus p to the power of 5. Okay, because that one's to the power of 6, that's to the power of 5. So we can just take that out. Remember, this works neatly because it's all multiply. So that's going to go entirely, and that just leaves us with this. Now, I reckon this looks quite doable from here. So 28, take away 28p equals 56p, add 28p to both sides. So that's going to give us 7084p, and divide both sides by 84 equals p. There we go. What's that? That's equal to a third. Okay, that was nice. Right, so let's look at one slightly trickier. Okay, it's the same idea. Okay, and again, if you feel confident, move on, or if you just go and have a go first of all. But I'm gonna work it through for you now. So I can do exactly the same thing. So I've got 8 choose 2, p squared 1 minus p to the 6, but this time it's 8 choose 4, p to the 4, 1 minus p to the 4. Now let's have a look to see what drops out. So 8 choose 2, remember that was 28. 8 choose 4 is 70. Okay, just doing that on my calculator, alright? Now, let's divide by p squared on both sides. So that disappears. p4 divided by p squared, that'll give me that. And now I'm going to divide both sides by 1 minus p to the 4. So that conveniently disappears. And I get that. Okay. 1 minus p squared is going to give, if you multiply that out, that's going to give you p squared minus 2p plus 1. And then need to multiply all of that by 28. That equals 70p squared. I've just got a quadratic, that's what it is. So if we multiply this out, what have we got? We've got 28p squared minus 56p plus 28, 70p squared. Let's take everything over onto the right hand side, so we haven't got a negative in front of the p squared. So 70 take away 28 is 40, 42 p squared. Add 56p to both sides, take away 28, and then that all equals 0. Common factor is 14. 14 goes into that 3 times, goes into that 4 times, goes into that twice. Have a little look, see if you can factorise that at all before you get started. I don't think it will. They usually do on these questions. I'm trying to have a little look at it. I can't see an easy route through there. So annoyingly, I'm going to have to use a quadratic formula. And if I sub in using a quadratic formula, it's going to give me -4 plus minus square root of 16. No, I've just done the 4 squared. Take away 4ac, so 4 times 3 times minus 2, and over 2 times 3 over 6. So that's going to give me -4 plus minus, that's 16, 12, 24, yeah, 40 over 6. And then that's going to give me, two answers. One's going to give me a negative answer. If I do the takeaway one there, it's going to give me a negative. Okay, so I'm going to reject that straight away. And then the other one that I need to do is I need to do -4. Let's just have a quick check, make sure it seems to work out okay. What have we got? We've got -4, just so you can see what I'm doing. And we're going to add root 40. And, oops. What did I do? Let's just get rid of that a minute. Just get rid of it. Just start again. Don't know what I did. Okay. Let's do it like this. Right. Okay. Right. I'm confident now. Right. That was a bit of a mess, wasn't it? Right. -4 plus root 40 all divided by 6. Okay. I'm not going to do the -1. As I said, I can see that's going to give me a negative answer. And what have we got? 0.387 to 3 decimal places there. Okay, right, you can see that there. Right then, so let's have a look at those, the next bit of this sheet. Okay, so what have we got? Next sheet I've got for you. Talked about this, about when does something become a binomial. Okay, so what are we looking for? We're looking for a fixed number of trials. Okay, so I do this a set number of times, 2 outcomes. So you could talk about the probability of something happening and not happening. And the fixed probability, the probability is always going to stay the same. And trials are independent. It's not going to be influenced. It's not going to change as you go through, right? So those are things that we're looking for. All right. Sometimes you get asked questions like on this question here. It's an old exam question, and sometimes it asks you stuff like this, and it says, state in this context 2 conditions needed for a binomial distribution to arise. So Andrew plays 10 tennis matches. In each match, he either wins or loses. So if we think back to what we're like, so we're going to play 10 tennis matches. So things, state 2 conditions needed to arrive in that context. So it's independent. You know, he's like, let's say his games, he's not going to improve his chances of winning or losing as he goes through. So the probability of him winning a game would always stay the same. And we need a second condition. It's already said about winning and losing, so we could refer to that there. We said about the probability being the same. He plays 10 tennis matches, so we could refer to him playing a fixed number, so it's 10 games that he plays. All right, so I can say virtually any of those things there. Right, part B. So assuming these conditions are satisfied, define a variable in this context which has a binomial distribution. So that's the number of games that he's going to win or lose. You could look at it the other way around. So x would be the random variable, the number of games he's going to win, all right, or lose if you prefer. I prefer to be positive, okay? Look at it in a positive way. Right, so part 2 then says random variable x is distribution. So we got n is 21, and we need to work out what p is. Yeah, look, you recognise this question? Very similar to what we had before. I'm going to quickly do this one for you. So we've got what have we got? We've got 21c 10 multiplied by p to 10 multiplied by 1 minus p. It should add up to 11, and then that equals, now remember lots of this is just going to drop out really nicely for us. Got 9 and then 1 minus p to the 12. Right, let's see what cancels out. Well, look, this p to the 9, I can cancel that, so that's going to give me that, and p to 1 minus p to the 11, I can take that out, so it's only going to be this bit over here that's going to be left. And the only things that are remaining to be done is I need to work out 21c10. So let's work out what 21c10, 21 choose 10 is. So there we go. What have we got? Ugh, horrible number. 3, 5, 2, 7, 1, 6. And then 21 choose 9. 21 choose 9. There we go. Equally horrible number. 3, 9, 3, 0. Okay, don't worry about it too much though, because if we, probably the easiest thing to do is to multiply this out. 2, 9, 3, 9, 3, 0. Take away 2, 9, 3, 9, 3, 0. P. Add this to both sides. So what's that going to give me? Add 3, 5, 2, 7, 1, 6. So 6, 4, 6, 6, 4, 6. P equals 2, 9, 3, 9, 3, 0. Divide by this. So we've got 2, 9, 3, 9, 3, 0. Divide by, and comes out to be 5 over 11. Okay. Right, and the last couple. I'm going to have a quick whiz through these two. Again, do the questions before me if you're happy about that. What have we got here? Suggest a suitable model to describe a number of people. Okay, right, so it's going to be binomial. How do I know it's binomial? Because we're talking about, he knows the probability of a passing person taking a leaflet. They either take a leaflet or they don't. So we're going to talk about the number of people actually taking a leaflet. So we're going to set this up. So and n is 30 because 30 people have gone past, and p is 0.3, and then we're talking about the random variable, the number of people who take a leaflet. Part B, what is the probability that more than 10 people take a leaflet? So we need to work out the probability that x is more than 10. Now if you remember in an earlier one, I said about if you're not sure, you kind of write the numbers. Obviously it's a bit much to go and write all the numbers 1 to 30. But what am I actually interested in? So 8, 9, 10, 11, 12, 13. I'm interested in that lot. What's the probability that more than 10 people? So it doesn't include 10 people. So I want these people over here. I want to work out the answer over here. So how to do that? Well, remember, all the probabilities together should equal 1. So the easiest thing to do here is to do 1 minus the probability that x is less than or equal to 10. And you can simply just use your calculator to go and do that bit there. Alright. And then our last example. Toss the coin. I know it's 3 times as likely to land on heads as it is on tails. So it's sort of expressed it a bit like it's done it like a ratio, hasn't it? So I'm tossing a coin. I know it's 3 times is more likely to land on heads as it is tails. Okay, so I could write it like that. What is the probability that it... So if I talk about a single go, heads is three quarters of the time, 0.75. Okay, tails is 1/4, 0.25. Just come back to this. It's 3 times is likely to land on heads. That's 3 times that. There you go. What's the probability that it will land on tails for the first time on the third toss? So what that means is it's got to go heads, heads, tails, right? Just got to think about what's happened. So that's going to be 0.75 times 0.75 multiplied by 0.25. What is the probability that in 10 tosses it lands on heads at least 7 times? Okay, so let's have a little think about what we got. So let's go and say, so we've got 10 goes. Chances of getting ahead are 0.75. What's the probability? So we could talk about, so x here is the random variable of number of times it lands on heads. Okay, and we want the probability that x is at least 7. Okay, what's the probability that it lands on heads at least 7 times? So x is more than or equal to 7. So in other words, it's 8, 9, 10. So I could work out the probability of 8 plus the probability of 9 plus the probability of 10. Okay, oops, and the probability of 7. Okay, so I could go and do that. Right, I want to do it a little bit quicker than that. So the easiest way forward on this is to reverse the question, and it's to do 1 minus the others. So if you do it this way round, less than or equal to 6, because that's really simple to do on your calculator, and it's just only one thing that you've done, right? Remember from my previous work. All right, and if you do it that way, it will be so much easier. Okay, and we're including the 7 this time because it said it lands on heads at least 7 times. So that means it lands on heads 7, 8, 9, or 10 times. All right, so hopefully you'll be all right now. You can have a go at doing those questions there. All right, and then over the next couple of lessons, again, we're just going to try and move this on a little bit further for you. Okay, all right, so good luck with those.